Greetings, folks. Joseph Kursky here with you to talk about how to quiz students and how to teach about classifying data into maps. This activity is part of a course that I teach called Mapping Our World. It's called the Classification Game. And students create 3 classification schemes for a set of numbers using different classification methods. Each classification will have 4 classes, which means they will have 5 class breaks or class limits. I love this activity. It teaches a fundamental skill in mapping. So let's talk about equal intervals. You're going to create a 4-class equal interval classification for the following distribution of values. Okay, it goes from 5 to 93. 93 to minus 5 is 88. So 4 classes, that's going to be 22 of a range between each one. So 5 to 27, 28 to 50, 51 to 73, 74 to 93. Each one of those is 22 in range. So therefore, when you go to this actual quiz that the students are required to complete, they enter those values in here. Now, why does this all matter? Because the way that you classify data affects your reader's perception of an issue or a phenomenon. So how you classify data is really a fundamental skill, not just in mapping, I would argue in lots of other fields as well, statistics and more. So we're going to enter those values in there. Each one of them is 22 wide or has a range of 22. And notice that it's not 5 to 27. The way that this particular LMS or learning management system is set up, I didn't have enough width, so I put 5 to 27 and then see the dash on the right side of the 27. 27 to 50 is the next range, 50 to 73, and then 73 to 93. So those are 22 wide, and that's great. Why does that matter? Once again, because classification matters in mapping. Still under equal intervals, sort each value into the equal interval class it belongs to. So now it's a matter of dragging those little elements which represent those numbers. It could be population, it could be water quality, it could be the number of cattle, whatever. Doesn't matter. But the students then, I think this is a nice reinforcement. So not only do they understand what the breakpoints are, but now each value has to be put into one of those categories. So you're just dragging and dropping those values in there. So we said 5 to 27 for the lowest class. So what do we have? 27 to 50 for the next one. So I'm going to drag all the values between 27 and 50 to that second class. And I also want them to note as they do that, that there are different numbers, a different set of numbers, a different value, a different group in each class. Because it's equal interval. So equal interval doesn't mean the same number of observations in each category or each class. That comes in with quantile, which we'll explore next. So now I'm going to go 50 to 73 for class 3. Everything that's between 50 and 73, that's only 3 of them. And now the highest class gets 4 values. And so notice there's 6 in class 1, there's 7 in class 2, 3 in class 3, and 4 in class 4. So that's equal interval classification. I also, in the discussion, by the way, have lots of maps in these different classification methods so the students will see the differences between each one of these. You're going to create a 4-class quantile map now. Okay, what does that mean? It means the same number of observations in each class or category. So what would be the 5 class limits for a 4-class quantile classification? So once again, okay, quantile equal number of values for approximately when the number of classes is not a factor of the total number of values. Okay, so we're going to put the same number of observations in each category. That's pretty easy. So we're going to start with the lowest value. It's actually 5, not 11, Joseph. So grab that 5 and put it up there. Notice that we've got 6, 6, and 8. So we have what? 12, 20? We have 20 observations and 4 categories or classes. That means we're going to put 5 numbers in each class, right? 20 divided by 4, 5. So we're going to go 20 total, 4 classes, yes. So 20 divided by 4, 5 in each class for quantile. Quant is not 5. It's a specific kind of classification method. Okay, so let's take 5, 11, what's next? We're just going to go numerically until we fill class 1 up with 5 values. Does that make sense? So 5, 11, 14, and 15, what's next in the numeric sequence? We've got a 22 there, but we also have a 19, so let's drag that 19 up there. Okay, So we've got 5 there. Now let's go with class 2. 22. What else do I have? What's next in the sequence? 32. There's a 33. What do we have? Any more 30s? 39 is there. Let's grab that 39. Okay, what about the 40s? 41. Okay, we've got 5, so we've got a break point there. We've got to go with the next. Look, there's a 40. Let's put that up in class 2. I missed that one. Okay, so 41. Any others in the 40s? There's a 50. There's a 46 in there. Let's grab that 52. Let's grab that 46. And we have 4. We need one more. What's going to go next? Even though it's quite out of the 40s and 50s, we've got to go with the 72 because we've got to get 5 values in class 3 and then 5 values in class 4. So that's easy. Whatever's left, we're going to dump into class 4. So now we've got 5 observations in each one of the 4 classes. That is quantile. Again, this is an important skill in mapping, and I love the way that this particular learning management system is set up so that you can do this sort of dragging and dropping. I think it really cements it, along with the discussions, as I mentioned, that show students what different classification methods result in terms of maps. Okay, so what about this? What would be the limits for that 4-class quantile? 5, we've got 5 to 20. Okay, what about 20? Look, it's different from the equal interval. That's what I want students to notice. 5 to 20, and again, because I've got the way that LMS is set up, 20 to 40, 40 to 72, 72 to 93. Okay, so that's the class limits for quantile. Now let's look at natural breaks. There's others we could look at, but let's just keep it to these 3. Natural breaks, quantile, and equal interval. We're not going to look at standard deviation and some of the other ones here. So natural breaks. So look at the numbers on the left. Select all the values below that would be logical places to break up the numbers into natural breaks. 77, I'm not sure about 77. Possibly. Yeah, 77 would work because there's a break point between 73 and 82. So what about 51? It's too close. Look at all those numbers right around 51. That's not a logical place. 12, no. 11 and 14 are too close. 25 works because there's a 22 and there's a 32. So that's a logical break point right there. If you were going to create a 4-class natural breaks classification for the distribution of values, what's the correct answer here? It's B. There will be a different number of observations or values in each class. That is, some classes could have 7 or 8 values, while other classes could have 1 or 2 values. That's exactly the right answer. Okay, so that is the classification game or quiz. 3 classification schemes for the numbers below using 3 different classification methods. I hope this has been helpful as you teach mapping, classification, visualization, and so on. Thanks for being with me.